Hi everyone, welcome back to the video lecture series on Renesas RA microcontrollers. In this video, I will show how to set up the development environment and get started with the FPB RA8E1 by implementing a simple Blinky project. Scan this QR code to open the RA8E1 product page. From this page, you can download the RA8E1 datasheet, user manual, and the required software and tools. The RA8E1 is a 360 MHz ARM Cortex-M85 based entry-line microcontroller with helium technology and ARM trust zone. From this feature list, you can find details of the available peripherals for the RA8E1. Scan this QR code to open the E2 Studio product page. From this page, you can download E2 Studio according to your operating system. Open E2 Studio, then create a new project by clicking on the File icon, then select New, then select Renesas C++ project, then select Renesas RA project. A new dialog box will appear. You can give a name to your project here. After naming your project, click on the Next button. From this drop-down menu, select FPB RA8E1 board. After board selection, click on Next. After that, select Flat, Non-Trust Zone project. For Smart Bundles, select the None option, then click on Next. Now select Executable and No RTOS option. Now select Bare Metal Blinky project and then click on Finish button. Now the IDE will take some time to configure your project. Now click on the Open Perspective button to open the FSP configuration file. In the FSP configuration file, click on the Stacks tab. By default, the IDE adds the GPIO stack based on the board design of the FPBRA8E1 board. When you open the Pins tab, you'll see that the pin settings are already predefined according to the FPB board design. If you open User Manual for RA8E1 and search for user LEDs, you can find that user LEDs are connected with P404 and P408 pin number. In FSP configuration file, if you expand P4 and open pin setting for P404 and P408, both pins are configured as output pins and symbolic name are given as LED1 and LED2. For this project, we don't need to change anything in the FSP configuration. Now, click on Generate Project Content. You can check the status indicator at the bottom left corner while the IDE generates the project content. Once it's done, expand the SRC folder and open the hal_entry.c file. IDE have implemented a Blinky project for onboard user LEDs. We can use RBSP pinWrite function call to control GPIO pin state, and we can use RBSP software delay to introduce blocking delay in the program. Now click on this hammer icon to build your project. After the build is successful, right-click on your project name, then select Debug, then select Renesas GDB Hardware Debugging. Now click on the Switch button to open Debug Perspective. As shown here, program execution is initially suspended at the system_init function inside the reset handler. When you press the resume button, execution continues and stops at the hall entry function. This is the point where the user application begins. Press the resume button again to start executing the user-defined code inside hall entry function. If there are no errors in the program, the status indicator will show that the application is running on the hardware. However, if an error occurs, the indicator will display an error state, and program execution will halt. Now if you check FPB board, both LEDs are blinking after every second.